This is a compiled review for stoichiometry, and we will see an example from each type of calculation. So the first conversion I'm going to talk about is mole to mole conversion. So the first question here is the combustion of propane is represented by the balanced chemical equation below. How many moles of propane are required to produce 3.34 moles of water? So what I will do, first I will check whether the equation is balanced or not. So it is balanced, and then I will look which are the two compounds of interest here. I can see how many moles of propane, so I will identify the propane from the balanced chemical equation and are required to produce 3.34 moles of water. I will identify where is water. So in this case, we have one reactant and one product. And then what I will do, I will start with the given quantity, which is 3.34 moles of water. And we have to find how many moles of propane. So how many moles of propane? So propane is C3H8. So and now I will arrange the conversion factor in such a way that moles of water will cancel and I should end up with the moles of propane in the numerator. Okay, so I will arrange the moles of water in the denominator first, and I will look at the equation to see how many moles of water. I have 4 moles of water for each 1 mole of propane, right? So now I can cancel moles of water and moles of water, and I have moles of propane in the numerator. That's what we want as per the question. And now we can write only the numbers in the numerator, that is 3.34 times 1 mole of C3H8 divided by, I have 4 in the denominator. So the numbers are 3.34 divided by 4, and I will get the answer 0.83 moles of propane. And now we will see a conversion between mole to mass. Okay, so how many grams of carbon dioxide are produced when 2.10 moles of oxygen are used in the chemical equation? C3H8 plus 5O2 gives 3CO2 plus 4H2O. So first what I will do is I will see the compounds of interest here. How many grams of carbon dioxide? I will mark that carbon dioxide in my equation, and 2.10 moles of oxygen. I will look where oxygen is and I will mark that one. So these are the two compounds I am going to relate. So the relationship between these two compounds we will find. And now I will start with what is given, 2.10 moles of oxygen. So I will write 2.1 moles of oxygen, and I will see the conversion factor between oxygen and carbon dioxide. So I don't want moles of oxygen. I want what they're asking, the grams of carbon dioxide. So I will write how many grams of carbon dioxide will form. Okay, so I need the grams of carbon dioxide in the numerator, and I want to cancel all other units. So first I have to start with cancelling moles of oxygen because that is what I started with. And now I will look in the equation. So I'm going to connect the dimensional analysis with the equation. So that means for 5 moles of oxygen, so the mole ratio is 5 moles of oxygen gives 3 moles of carbon dioxide. And now I can cancel moles of oxygen and moles of oxygen. And now again, I don't want moles of carbon dioxide. I need grams of carbon dioxide. So I know in 1 mole of carbon dioxide, I have how many grams? 43.9 grams of carbon dioxide. If you take the masses from the periodic table, you can see that carbon is 12.01, oxygen is 15.99. I have two oxygens, so 15.99. That will give you 43.99. Okay, and now I can convert moles of carbon dioxide and moles of carbon dioxide, and I ended up with grams of carbon dioxide. And now what we have to do is take the numbers in the numerator, 2.1 times 3 times 43.99 divided by, in the denominator I have 5 times 1, and what is left, the unit is grams of carbon dioxide. So that equals, when you multiply those numbers, we will get 277.137 divided by 5. I will not round until I reach the final answer. Okay, so I will leave all the numbers like that. So that will give me 55.4 grams of carbon dioxide. So how many significant digits I need? 2.10 means I need 3 significant figures. So I can write 55.4, that is correct significant number, grams of carbon dioxide. And now let us say a conversion that is between mass and volume. Okay, so for this one, what the question is, how many liters of oxygen gas are required to react with 46.5 grams of propane? So first what I will do, I will see which are the two components we have to connect, propane and oxygen. So I got that, and it is a balanced chemical equation, and then I have to start with what is given. 46.5 grams of propane is given. I don't want the grams. I always convert it into moles so that it is easy for me to connect with the equation. So I know the grams of propane in 1 mole. So I will write the grams of propane in the denominator. When I find the mass of 1 mole of propane, I see that it is 44 grams. So that is, in 1 mole of propane, I have 44 grams of propane. I'm writing the grams of propane in the denominator so that I can cancel, because I don't want that grams. And now I can connect the moles of propane with our equation. So that means 1 mole of propane, the mole ratio is, that corresponds to 5 moles of oxygen from the balanced chemical equation. So I can cancel 5 moles, moles of propane and moles of propane. And they are asking for the volume. So I don't need the moles of oxygen. And I know the conversion factor between moles and volume. So 1 mole of oxygen at STP. If it is not mentioned at STP, it should be at STP. So that 1 mole is 22.4 liter. Okay, so 1 mole of oxygen is 22.4 liter of oxygen. That is, moles of oxygen and moles of oxygen cancel, and I am having the liters of oxygen in the numerator. That is what is required, correct? Because they are asking how many liters of oxygen. So now I can just take the numbers from the numerator and multiply and divide with the numbers in the denominator. So 46.5 times 1 times 5 times 22.4 liters of oxygen divided by the numbers in the denominator, 44 times 1 times 1. So that equals 44. Okay, so that equals 118 liters. I need 3 sig figs, so that is exactly what we have. Here is another question. So that is 39 grams of zinc are reacted with 42.6 grams of hydrochloric acid. How many grams of zinc CnCl2 will be produced? Which reactant give the smallest amount of reactant? That means we have to find the limiting reagent, and they specifically say which product we have to consider, that is CnCl2. So I will first find with the Zn, and then I will find with the hydrochloric acid, and then I will see which one gives the lowest number of moles. Or since they said the grams, I will go with the grams. Okay, I will find the mass instead of moles. Okay, so let's go ahead and start with the first one, which is Zn. Okay, So that means 39.5 grams of Zn times the conversion factor. I have to convert that one into moles. So 1 mole of Zn, since the grams given, I have to always convert that one into moles to compare with our equation. So if you look in the periodic table, you can see the molar mass of zinc is 65.39 grams of Zn, and then I will connect that one with the equation. That means 1 mole of zinc, stoichiometric relation between zinc and ZnCl2 is 1 mole of ZnCl2. So I will not stop at moles because they said grams. So I will convert that one into grams. That means in 1 mole of ZnCl2, if you calculate the molar mass, if you look in the periodic table, Zn is 65.39, chlorine is 35.45. There are 2 chlorine, so 35.45 2 times. That equals 136.29. So that will go in the numerator, 136.29 grams of ZnCl2. And that's all I need because I will get it in grams. So moles of CnCl2, moles of CnCl2, moles of Cn, moles of Cn, grams of Cn, grams of Cn will cancel, and I will have grams of CnCl2 in the numerator, and other numbers are 39.5 times 136.29 divided by, I have 65.39, and the unit here is grams of ZnCl2. So I will have 82.8 grams of ZnCl2. And now let's go ahead and see for HCl. So for HCl, we have 42.6 grams. So second one for HCl, 42.6 grams of HCl. The convert it into moles. So that means when you take the molar mass from the periodic table, we will get 36.5 for HCl in 1 mole. Okay. And I have to see the relationship in the stoichiometric relationship in the balanced chemical equation. So 2 moles of HCl corresponds to 1 mole of CnCl2 from the balanced chemical equation. Now I had to convert that moles to mass. 1 mole of CnCl2 equals 136.29 grams of ZnCl2. Okay, and now we can cancel grams of HCl, grams of HCl, moles of HCl, moles of HCl, moles of CnCl2, moles of CnCl2. So which are the numbers in the numerator? 42.6 times 136.29, and the unit is grams of ZnCl2 divided by the numbers in the denominator, 36.5 times 2. That will give us 79.6 grams of ZnCl2. So we have less number of grams of the product here. So HCl is the limiting reagent. Okay. So which reactant gives the smallest amount of CnCl2? That's a question. So HCl gives the lowest number or smallest number of the product. So that's the limiting reagent, and zinc is our excess reagent. Let us try the same question with the cross multiplication method. Those who go with this one, what we will do first is we will go ahead and write what is given in the question. So in the question, I have 39.5 grams of Zn. So I wrote that just below Zn in the equation. So as usual, if it is in grams, I will convert that one into moles. So from the periodic table, 65.39 is the molar mass of Zn. That will give me 0.6 moles of Zn. And I will see from the equation, how many grams of ZnCl2 is formed, but I can see the moles first and then convert it into grams. Okay, so how many moles first I will calculate, and then from the equation I will see 1 mole of Zn, that is the coefficient here, and the coefficient of ZnCl2 is 1 mole. So 1 mole of ZnCl2, and then cross multiply. So I will have 0.6 times 1. So that means I will have 0.6 moles of ZnCl2. And now convert that one into grams. So I know 136.29 is the molar mass of ZnCl2. So that will give me 81.7 grams of ZnCl2. And now I will cut, this is for Zn, and now I will do for HCl as well in the same method. So for HCl, I have from the question 42.6, sorry, 42.6 grams. I will write below HCl in the equation, and I will find the molar mass 1 for hydrogen, 35.5 for chlorine, that equal 1.169 moles. And from the equation I can see that there are 2 moles of HCl, and I will find how many moles of ZnCl2, and from the equation I see that 1 mole of ZnCl2, and then cross multiply I will have 0.584 moles of ZnCl2. I will multiply the moles with molar mass, that is 136.29. That will give me 79.59 grams of ZnCl2. So 79.59 is smaller than 81.7 grams. So HCl is our limiting reagent.
Solid copper 1 sulfide reacts with oxygen gas to form copper 1 oxide and sulfur dioxide gas. How many grams of copper 1 oxide will be formed from the reaction of 75 grams of copper 1 sulfide and 21.5 grams of oxygen? If 55.8 grams of copper 1 oxide are produced, what is the percentage yield? So 2 questions here. So first what we will do is, since we have the word reaction given, we have to write the symbol equation first, and we have to balance it. So copper 1 sulfide. So copper 1 sulfide is Cu2S. Sulfur is -2, copper is +1. So we will have Cu2S that reacts with oxygen. And this is solid. This is gas. And we will have copper oxide, that is solid, plus sulfur dioxide gas. And now when you balance it, we can see 2 and 2 and 2 here and 3 here. And now from the equation, so from the question we have 75.0 grams of copper 1 sulfide and 21.5 grams of oxygen, and it also says we have 55.8 grams are produced, that is copper oxide are produced in the lab. That is going to be our actual yield. Okay, and now what we have to do is, since we have the information for both reactants, we have to find which one is the limiting reagent. So the limiting reagent I'm going to find for Cu2S, that's a reactant, and I will see how much Cu2O will form. Okay. For that one, I will start with what is given. So I have 75 grams of Cu2S and divide by 1, and I will convert that mass into moles. So we know in 1 mole of Cu2S we have 159.152 grams of Cu2. Yes. So first I have to convert it into moles. And then I can convert that moles to the ratio of moles in the equation. That's the mole ratio between copper 1 sulfide and copper 1 oxide is 2 moles of copper 1 sulfide. The mole ratio is 2 moles of copper 1 oxide. So how much is that going to be? The grams of copper 1 sulfide, grams of copper 1 sulfide cancels, moles of copper 1 sulfide, moles of copper 1 sulfide cancels, and we will have moles of copper 1 oxide. So we can have the numbers from the numerator 75 times 2 moles of copper 1 oxide divided by 159.152 times 2. So 2 we can cancel, and 75 divided by 159.152 equals 0.47 moles of copper 1 oxide. And then we will see the other reactant oxygen, how much copper oxide it will produce. Okay, so for that one I have 21.5 grams of oxygen given, divided by 1, and I can convert that one into moles. So we know in 1 mole of oxygen, the molar mass of oxygen is going to be 31.98 grams of oxygen, right? And then that moles of oxygen, I will compare the stoichiometric relation, the mole ratio in the balanced chemical equation. So 3 moles of oxygen, 2 moles of copper 1 oxide. Now I can cancel grams of oxygen, moles of oxygen, moles of oxygen. I will have moles of copper 1 oxide. So I have the numbers that equal 21.5 times 2 moles of copper 1 oxide divided by 31.98 times 3 in the denominator, that equal 43 in the numerator, 95.94 in the denominator, that equals 0.45 moles of copper 1 oxide. So which one is the lowest number of moles here is 0.45 moles of copper oxide. So we got that one using oxygen. So oxygen is the limiting reagent. Okay, and then we can find the second part, that is, okay, they're asking the mass of copper 1 oxide. So mass of copper 1 oxide equal moles of copper 1 oxide times molar mass of copper 1 oxide. So that equals now we can say that 0.45 moles of copper 1 oxide equal, in 1 mole of copper 1 oxide we have 143.09 grams of copper 1 oxide, that equals 64.39 grams of copper 1 oxide. And now we can find the percentage yield. So the percentage yield equal actual yield divided by theoretical yield times 100. So that equal 55.8 divided by 64.39 times 100. So that will be 86.65 percentage. Alright, so now we can see the cross multiplication method. So first we can write the equation. So that is 2C2S plus 3O2 gives you 2Cu2O plus 2SO2. And then we have 75 grams of copper, 1 sulfide. So I will write 75 under Cu2S. And we have 21.5 grams of oxygen. So I will write 21.5 grams under oxygen. And now first I will go with the copper 1 sulfide and I will see how much copper 1 oxide will form. So I will find the number of moles by dividing with the molar mass of copper 1 sulfide and I will get 0.47 moles. So now I can see the mole ratio, that is 0.47 moles will give how much copper 1 oxide. So I know from the balanced equation 2 moles, because here too 2 moles of copper 1 sulfide will give me 2 moles of copper 1 oxide, 1 to 1 ratio, correct? So how many moles of copper oxide will form from 0.47 moles is the same number of moles. So that means I will have 0.47 moles. Okay, so that's what going to be the number of moles of copper 1 oxide from copper 1 sulfide. And now I will see from oxygen how many moles will form. So then 21.5 is the mass of oxygen divided by the molar mass of oxygen is 31.98, that equal 0.67 moles I am getting. And now from the balanced equation I have 3 moles of oxygen and that gives 2 moles of copper 1 oxide. Okay, so how many moles will form from 0.69? 0.69, how many moles? So what I will do, just cross multiply, right? So the number is 0.67 times 2 divided by 3, that will give me 0.45 moles of copper 1 oxide. So when you compare this one, that is from copper 1 sulfide, and compare the moles formed from oxygen, the number of moles of copper 1 oxide formed from oxygen is less than number of moles of copper 1 oxide formed from copper 1 sulfide. So this oxygen is the limiting reagent. To find the mass of copper 1 oxide formed, we will just multiply the number of moles with the molar mass. So number of moles we have to take for the limiting reagent now. So because that decides how much product it will form. So 0.45 times the molar mass of copper 1 oxide is 143.09, that equal 64.1 gram of copper 1 oxide. So that's the mass. And now we can find the percentage yield using the formula actual yield divided by theoretical yield times
64.39, that is grams of copper 1 oxide formed or calculated. Okay, and then we can calculate percentage yield. Actual yield divided by theoretical yield times 100, that equal 55.8 divided by 64.39, that equal 86.65%.